I'm SriRam. I'm the event coordinator. Uh, I'm a computer science major and the second year. And today I'll be talking about cryptography. So, what is cryptography? As defined by Merriam-Webster, cryptography is the encrypting and deciphering of messages in a secret code or cipher. So basically, just putting it in a way that it's harder for people to understand. So that if you want to send like a secret message, or you don't want people to know exactly what you're saying. And usually, the main tools will be using CyberChef and Decode. These are the two most useful ones, but each cipher usually has like a own website where you could that's specialized in it, and I usually find that that's usually a bit better to use, or at least a bit easier to use. Like for example, there's this time last time where there's a Jefferson wheel cipher, and you had to use this one specific site. All other sites didn't all work. So here's some examples of some common ciphers. So all of these are the hackback, just in different types of ciphers. So the first one is a ROT13 cipher. Right. Yeah, let's see. So as you can see, it shifts all the letters over by 13 and in a code. So like a B would be O, A would be N. There's a short for E. It's a type of Caesar cipher, which a Caesar cipher is like a more broad description of it, where it, so a Caesar cipher and shift cipher are the same thing, but instead of being by 13, it could be by any amount. Caesar cipher is usually 7, I believe, um, but ROT 13 is specifically 13. Uh, is it 3? Yeah, yeah, it's one of those two. But um, if I open up CyberShell right here, insertion. Sure. You maybe to use that's on top. It's just called rocket team. The thing is to copy the um, if I was to copy the encrypted text and then paste it in here, you can see it goes back to the original that happened. So all you have to do for this one is drag and drop. Um, if you want, you could also search up a Caesar cipher, a Caesar cipher decoder. This is decode. This is the other one I mentioned, but it's something like crypty. Uh, 13. As you can see, it also goes back to the hackpack. There's also AppBench. This one, it's also a substitution cipher, except it just reverses the string. So A becomes Z, B becomes Y, so on and so forth. Vinegar cipher is a bit more complex. It takes so it takes two it takes a encrypted code and a key, and it matches the words. So if it was Technical University and Houston, uh, it takes M and H, um, and then you get T, and then you just go on over until you get this string of code. So if I was to go back here, good. So this is the hack, and the key for this is UJ. So let's go to CyberChef and yep, it's French, so it's spelled weird. Yep. And that was yep. As you can see, it's the hackback. And then the real fan cipher. This one's actually pretty cool. Pretty cool. I like it. Um, it yeah. Mhm. Yeah. So a real fence, how it works is mm, makes it into like a zigzag pattern and then shuffles it like that. So because of that, it's a bit hard for like a decryption uh, finder to identify it. Um, And then this is Morse code. I'm pretty sure many of you already heard about it. Uh, sure. Yep. Um, and this it's a series of dots and dashes. Uh, it's commonly used for like a if you can't really speak, like SOS is usually uh, the most common one. Uh, Sometimes this could also be an audio file. So um, mhm, yeah. So if you hear a sound like that, um, that could also lead. That could also be a Morse code cipher. And then those are like some of the most common ones. And these are more other common ones, which are more numerically based. Let me just close out the ones we already did. So the first one is binary. If you took any sort of pure class, you probably already know what this is. It's in base two. Real simple. Just if it's ones and zeros, it's probably binary. Next one, hexadecimal. I'm sure many of you also heard this one. It's base 16, and generally speaking, if you see a 0x like this, that's a good indication that's hexadecimal. Um, and here, next. Yep. And then the um, other most pretty common one is base 64. Uh, and this one, it's usually identified by the equal signs at the end. So the reason why there's equal signs at the end is because uh, the when it's encrypted, it takes it in chunks of three. So no, yep. So it takes in chunks of three, and the hackback it has 10 characters. One, two, three. Yeah, 10 characters. So there's one X, or how much is the? Uh, yeah, 11. So there's it has to have one filler character in order to uh, make it a multiple of three. So for example, if I was to put um two yeah, yeah. So if I was to add the extra S, it would remove the equal sign. If I was to make it only 9 characters, it would another equal sign. Yeah. And here's some charts if you want to take screenshots. You won't really have to memorize this ever, but you can see, yeah, you can see how like the numbers match each character. Another cryptography is steganography. This is where a code is hidden inside an image. You can see, like with this numbers, it's sort of similar to those colorblind tests, where uh, depending on which color you have, you could see that code. Sometimes you could also have code hidden inside where you can't really see it. Um, like for example, this image. If you look at the first line, it's in the original image, it's R202021, B75, whereas this one is R2030113, B75. And usually you need to use some sort of tool to identify it in this case, as it's not always visibly noticeable. A good one is a Perry solve. So you just upload the image to it and it will do a bunch of tests. You can also use a bunch of tools in Unix. Some of them are built in, some of them you have to download. Uh, Yeah, yeah, like in case you didn't hear, Kali has a Vinlock, which you can use. Another pretty common one that's used in quite a few CDFs is RSA. So RSA cipher is commonly used in order to encrypt data when sending it, or at least it used to be, but now there's ways to easily crack it, so it's no longer used. Um, and how it works in a when you're transmitting data is you get a plain text, you get a public key, which encodes it, and then the person on the receiving end has a private key, which only they can use to decode it. There's also a mathematical algorithm they use, which it's nearly like it's pretty complex. So you get like two prime numbers, and then that gets you the oh, my bad. Uh, and it's really hard to do by hand, but if you have a computer, it's not a problem.